are going to discuss about an AWS end-to-end project called CloudClass, a smart platform for faculty-student collaboration. And coming to project description, a university called TechBridge. So faculty and students in the computer science department often face difficulty managing course content, project submissions and evaluations due to the lack of a centralized digital platform. So traditional methods using emails and offline submissions create confusions. So delays and inconsistent communication between students and faculty. So to address this, the university's cloud development team launched CloudClass, a full-featured cloud-based platform for managing academic workflows, built with Flask for backend logic, and the system runs on AWS EC2 for scalable hosting and uses AWS DynamoDB for storing user profiles, courses, activities and evaluations. The application enables faculty to upload course content, evaluate student projects and monitor performance, while students can enroll in courses, submit projects and take quizzes and view notifications in real time. So by streamlining academic interactions and securely storing records on the cloud, CloudClass improves transparency, reduces manual workload and enhances the learning experience for both students and faculty. So coming to scenario 1, so that is streamlined project submission for students. So in the CloudClass platform at TechBridge University, AWS EC2 provides the scalable infrastructure needed to support students accessing their dashboards concurrently. For instance, a student logs into CloudClass, selects a course and uploads a project file using the project submission feature. So the backend built with Flask handles the request efficiently and stores the submission details in AWS DynamoDB, including the timestamp and filing. This allows faculty to access the submissions instantly even during peak periods such as that could be exam weeks, ensuring smooth and reliable operations. And coming to second scenario, it is seamless course content delivery by faculty. So faculty members can log into CloudClass and upload study materials or reference links for any course they manage. When content is uploaded, Flask processes the request and updates the relevant course entry in DynamoDB, adding new material links, and also students enrolled in that course can instantly access this updated content from their dashboard. So the cloud native hosting on AWS EC2 ensures consistent performance, making it easy for faculty to manage and distribute digital content without relying on physical handouts or outdated portals. And coming to scenario 3, that is transparent quiz attempts and result tracking. So after project submission, faculty can view all student uploads directly from their dashboard and assign grades. So the complete scenario 3 explains about the quiz attempts. The quiz attempted by the students is evaluated and also the grades are mentioned in students dashboard. So this notification is displayed in the students dashboard, confirming the grade and providing quick feedback. So the system avoids manual flow-ups and emails, making grades transparent, centralized and fast, especially helping during semester end evaluations. And followed by architecture. This is the architecture which completely explains about the workflow of the website. Here you can see the arrangement of front-end web pages to back-end, EC2 hosting for deploying our project publicly, and DynamoDB for data storage, and AWS IAM for access control. And followed by entity relationship, diagram. So here for our project we are going to use three database tables, that are users table, courses and activities. Coming to users, we are going to store information about user, that could be faculty or student, and their email, name, password and the role, faculty or student. And coming to second table, courses. So the courses updated or uploaded by faculty was stored in this table. And then next, activities table is the one which stores all the information from faculty and student and all the activities from there, that could be score, evaluation, message, notification, a time they are submitting, each and everything are stored in activities table. And one more important thing is prerequisites, that is, first we need to have a AWS account setup. If you don't have one, either you have to create one account or else we will provide you an IAM user account to build the project. And next important thing is understanding IAM, identity and access management, which is very important, because you have to understand why we need IAM or creation of IAM role in a project. And next we need basics of EC2 and DynamoDB, or if you want to include or integrate real-time notifications like SNS, then you can also have idea about SNS. Then it is very important that you have to have and know about GitHub. You have to have a GitHub account. There you need to know how to create repository, how to upload all the files in that, and how to get a URL to clone all the files to deploy publicly. And next, this is the project workflow which we are going to follow to build a project. First, that is, as we discussed, we need to have a AWS account setup and we need to log into that. If you don't have one account, either you have to create one or else we will provide you with one account. And next, the main point is you have to set up DynamoDB tables, that is DynamoDB database creation and setup. There you have to create three tables, that is faculty, student users, courses and activities, and you have to configure the attributes over there. And next, backend development and application setup, which is very important, where you have to develop the backend using Flask and integrate AWS services using Boot03. Boot03 is the library which we are going to use to connect AWS services with our backend Flask app. And next we have IAM role setup. There you have to create IAM role and also attach policies. As I've told, you need to understand why we are creating IAM role here. We are giving permission to EC2 to access DynamoDB tables. So that's why we need IAM role and we have to set up it. And then we have EC2 instance setup. There we have to launch an EC2 instance to host the Flask application, then configure security groups for HTTP and SSH access, and followed by deployment on EC2. Here we are going to clone our all GitHub files to EC2 instance and terminal, and we are going to deploy our project. In the next step, we are going to test our website and storage of data in database. So we will follow these steps one by one and build our project and understand how to build a project. So first, milestone 1, this is logging to our Amazon or AWS account. Here you could create or log into your root account, or else you could also use give an IAM account. Both will be same. And the next main important thing is milestone 2, that is DynamoDB database creation and setup. Here this is the AWS management console. Here what you need to do is, this is root account. If you use IAM account also, the dashboard will be same, but the accessing of services will be limited in IAM account. That is only the difference between root and IAM accounts. So here first we need to set up DynamoDB tables. Here you could select from this main dashboard, or else in search bar you could type for DynamoDB. So in a document we have mentioned the same. If you search for DynamoDB in the search bar, it will open you in this way. Just click on DynamoDB, the first service which is looking, then it will take you to DynamoDB dashboard. Here on the left side you can see dashboard, tables and explore items. There you have to click on tables. So if you click on tables, this dashboard, it will open. There, to create one table you have to click on create table. So now we have to create 3 DynamoDB tables, that is faculty, student, users table, courses and activities. Here first create faculty, students, users table with partition key email with type string, and click on create tables. Then if we click on create tables, it will open you this dashboard. There you have to give table name, partition key as email and type should be string, and remaining things will be default, and last you will have a button called create table. You have to click on it, and next you have to follow the same steps to create courses and activities by configuring the attributes. And if you see here, to create courses we have used partition key as course name, and this will be given by faculty only while uploading. And next, while creating activities table, if you see here we are using a with partition key as user email. We are also using a sort key which is activity type ID, which is very important. If you don't mention sort key in activities, like the things which are created at second time with the same email will override the first one. If you want, you can also test it, because the things are only storing by the user email, the second things which are stored by the same email, because then there will be no difference. The main ID will be only email, then that will override the things on before things. Further, to make a difference, we are also mentioning a second type of key, that is sort key. Here we are giving activity type ID. Here we no need to give any specific ID by ourselves. According to the activity, it will take default one. Just we need to mention it over there. So when we have given all these things, simply if we click on create table, it will create all these tables: activities, courses and faculty, students, users. These are the 3 tables we are using for our CloudClass website. So if you are done creating this 3 tables, then you are successfully set up your DynamoDB database. And next we have to follow our next milestone, that is backend development and application setup, which is very important. because this is the main step where you are going to build your complete website. So this is the file explorer. Let me show you in the VS Code. So for building our website, mainly we need a folder, that is main folder for our CloudClass. Here we have named it as faculty and student, and next subfolders are three: static, templates and utils. In static templates it is storing images, and also if you want to store styling code also, you can store in static file. In template it is storing all the required web pages, that are HTML pages. So course detail, evaluation page, faculty dashboard, student dashboard, register page, quiz page, upload content page, payment page, notifications, all the web pages were mentioned in templates folder only. And next in utils, if you see, we have data.py. So in data.py it will store all the temporary database things in data.py. It is storing like if the information is temporary, we can store in this format. Okay, and meanwhile here in our website with temporary storage we are also using here. From here we are fetching from temporary storage. If you want, you can also store them in permanent DynamoDB database and can also fetch from there. Next main important code is app.py. Here in this code we are going to mention each and every routing for all HTML pages. First here we have to load all the necessary libraries. Then if you see Flask, we are going to use a date and time to save or store the details with the specific date and time. And coming to Boot03, that is the main library which we are using to connect our AWS services with our backend Flask app. So that is very important library. If you see here, we have given AWS setup, that is DynamoDB. We have our DynamoDB, we have connected to Flask with boot03.resource function, and here we have also mentioned the region on what region we are going to, or we already created DynamoDB tables. That region we have to mention it here, and the DynamoDB, and these are the three variables which are storing the three tables which we have created in DynamoDB database, if you see here. And next we have to initialize the Flask. Then we have mentioned all the routes over here. If you see, you would have gotten the doubt by now. While creating database, we just have mentioned the table name, partition key, or if needed, sort key. What about other attributes or other columns needed? So those things we are going to mention in Flask. If you see in users table, here in users table we have storing faculty, student, users data. Those things we are going to mention over here. Email, name, password and role, followed by login, logout and student dashboard. So each and everything in faculty dashboard root. And upload content. Here upload content, this is done by faculty, and from here in course table we are storing data, like that is course name created by, and material links we are storing from this route. And then payment route, from payment route we are like, if we are done with payment, then that is like a specific student have enrolled into specific code. That details we are storing from this route. In activities table we are storing user email, activities, type ID, message and timestamp. And next followed by submit project, same things we are going to store in activities table only, and then course name. This is quiz. Even this information we are storing in activities table, followed by notifications. These are the notifications which triggers when specific activity done by student or faculty, mainly student. And next, evaluate page. Here in activities table it is storing evaluation details, and followed by the running of our Flask app. Here app.run function is telling each, and here it is mean that even in your code this Flask app should be in the same format. If you want to change, you can change the port to the default port like 5000. Here I have used the port type as HTTP with HTTP port number, and host should be seen and debug should be true only. And here for we are using port range is 80, just remember that. So if you are done successfully building your backend, then you have done with this part also. Then we have to follow the end step, that is we have done building our backend, which we have mentioned each and everything in our document, and we have deployment code also. Then next we have IAM role setup. Here we have to create IAM role. So in management console, like in the similar way from DynamoDB, how we have typed in search bar, go to search bar, type for IAM. In the similar way, on the left hand side you can see roles over there. In the IAM dashboard, so click on roles. This dashboard it will open. There you have to click on create role, and this page it will open you. So you have to choose trusted entity type as AWS service and use case as EC2. Then have to click on next, and in add permissions case you have to add Amazon DynamoDB full access as we are showing here. And if you are done selecting it, just click on next and attach policies. If you have also like integrated SNS service, here in this case you also have to give permission to EC2 to access SNS also, and that here in our case that is optional. And next, in add permission case, if you have SNS you can follow this step or else leave it. And then if you click on next, it will open you this page. Here you have to give role name. Here we have given the services which we have used like EC2 underscore DynamoDB underscore SNS. And if you see here add permissions case, the permissions you give to EC2, you can see it here. And if you click on create role, it will successfully create you the role. So if you're done with that part, then you have successfully done setuping IAM role also. Then now you have to follow setuping EC2 instance. And before that, what you need to do is you have built completely backended, also connected your DynamoDB tables to your backend. So now you have to upload all them in your GitHub account. You have to create a repository and load all your files into that repository, and there you can see a code button like this. If you click on it, you can see with the code HTTPS one URL. You have to copy it and have to save to connect, because this is only this URL which helps in connecting or cloning all this files to our EC2 terminal to deploy a project publicly. So save it this. Next, In the search bar, type for EC2, and in the left side in the EC2 dashboard you can see instances. Here click on instances. This page it will open you. There if you click on launch instance, just follow this part. There you have to give a, in launch instance names and tags, give a name, instance name, and as a Amazon machine image or AMI you have to choose either Amazon Linux or Ubuntu. So Ubuntu is the AMI we have used for this project. So choose it, and then you have a type, instance type, you have to choose it as t2.micro, and then you have to create a key pair. Follow the steps, give a key pair name, key pair type should be RSA, and file formatting should be .pem, and if you created it, it will automatically select you in the key pair section in this method. And then next activity is configuring the security groups. Here that is the main part. While it's starting you can only see SSH. There you have to click add security group and have to this. We have, if you remember, we have used port as 80 HTTP. The same thing, as a type you have to choose HTTP, port range 80, and source type should be anywhere, then only it will take source as 0.0.0.0. And if you are choosing, for instance, if you are choosing a default port as 5000, so then type should be TCP only, and port range should be 5000, and source type will be always anywhere only. And then if you are done with configuring security groups, you are done with setuping EC2 instance also. Your next step will be, after successfully creating an EC2 instance, what you need to do is, here you have to select the EC2 instance. Here I have used the instance which is already created. So for instance, even though I have showed you how to create, here the instance we have used is which is already created, and here just choose it. Here you can, here even though it is like stopped, instance state is stopped, it should be running. To be active it should be running. If you go to instance state, you can make it run even though in this image it is stopped. Here you can see actions button, right? If you click on instance ID over here, it will open you this. Even though here you can see the IAM role is already there. If it is empty, or it will be empty when you create it newly. So further to connect your IAM role which you have created already to your EC2 instance, what you need to do is just come to instance ID. Here you can see actions button, right? Actions button. Here just click on actions, security, and followed by modify IAM role. If you click on that, it will take you to this page. There you can choose the IAM role which you have created, and if you click on update IAM role, it will successfully update you in this method. Then next step, what you need to do is, once again select the instance, and you can see your connect button, right? That will be enabled only when the state is running. So make sure your instance is running, and if you click on that connect button, this page it will open, and just click on connect button, and this is the terminal for Amazon machine image Ubuntu. So if you have come till this step, then you are successfully done with setting the all AWS services. Now your step is deployment of your project, that is CloudClass. For that, what you need to do, here in terminal, one by one you have to run all these commands. First you need to update or install all your Python and pip files, then you have to load all this and also have to install Git. And a virtual environment, very important, because if it is Ubuntu, it need a virtual environment, and also activate it. After activating your virtual environment, this is main step. After loading all our files in GitHub repository, if you remember, we have stored or saved the URL, right? The same URL you have to clone it here using this command, that git clone and the URL. After that, to navigate to the project, you have to use this command. After successfully navigating, install all the necessary modules which you have used in your backend code, that those are libraries. And to launch the website, you need to use this command, that is sudo, we are using virtual environment, right? That is vnv and then python3 app.py, and it will successfully run you the app in this way. And if you see here, this is the terminal. You can see public IP, right? This is the main URL. After deploying your project publicly in terminal, you have to use this link or IP in your browser. Just copy paste it in your browser, then you can, in this method like HTTP and your EC2 public IP, then it will successfully open you the CloudClass website. So if you see, this is the home page of our CloudClass website. This is about us page, contact page, and this is login page, registration page, and faculty dashboard. This is the dashboard of faculty. Here you can see project submissions, evaluations done, quick actions and upload materials, evaluate projects, and course uploading. If you click on upload projects, you can upload in this way. So one by one evaluate projects. And this is the student dashboard. This is different from faculty dashboard. Here you can see my courses. These are the enrolled courses which paid payment, and if the faculty added a new course, it will be visible in available courses, that is AI, that course which is added by faculty. If you click on enroll, that will take you to payment page. If you are successfully done with payment, it will take you to my courses, and the courses added into your courses, and then each and every notification for your activity will be shown like this. And then course material page. So if you see, if you want to see view materials, if you click on that, in this way the material link will be visible. You can navigate through that. And project submissions, you can submit your projects in this way, and the same. So the projects you have submitted will be visible to faculty in this method. And the quiz, if you want to take the quiz, you can click on quiz button and take the quiz, and the quiz results will be shown like this in the student dashboard. And coming to project evaluations, the project submitted by you will be looked like a link to the faculty, and after evaluating each and everything, the faculty will give the grade, and if he submit the grade, he can see the evaluations done to the so and so person, and the grade you obtained it will be looked like this in the student dashboard. So then if you are done till here, we have successfully accessed our CloudClass website. Now our work is to DynamoDB database updation, that is testing our tables. Here if you see, here for this what you need to do is, in DynamoDB database updations, Here, if you go once again, you have to navigate to DynamoDB. There on left side, you will see explore items. Explore items. Over there, if you select the your faculty table you have created, you can see the data stored over there in this format. So once you have done, congratulations, you have built your AWS project and end-to-end project successfully. And coming to conclusion, so the CloudClass web platform has been successfully developed and deployed as a comprehensive solution to manage faculty-student interactions in an educational environment. By leveraging AWS EC2 for hosting, AWS DynamoDB for persistent data storage and Flask for backend logic, the system provides a seamless interface for both students and faculty to interact in real time. So this platform efficiently addresses the fragmented nature of project submissions, evaluations and course content distributions by unifying them into a single cloud-based portal. So students can enroll in courses, submit projects, take quizzes and receive timely updates through the system, while faculty can manage submissions, evaluate performance and deliver materials. So all from a centralized dashboard, real-time alerts and notifications are efficiently handled through the activities tables and access securely managed through IAM roles. So the cloud native architecture ensures the platform remains scalable, resilient and high performing even as the number of users and interactions grows. By eliminating the constraints of traditional paper-based or offline workflows, CloudClass transforms the academic engagement process into an efficient, transparent and accessible system. So in conclusion, CloudClass showcases the power of combining Flask with AWS services to solve practical academic coordination challenges, reinforcing the potential of cloud-based platforms in modern education. Right, we have successfully built an student and faculty management project. Right, thank you.